All right, so it is 9:30. We will go ahead and get started. Hi, everybody. I'm Brent Ozar. I'm going to be talking about 3 hard performance problems, which, if I was going to go back in time and pick the session I was going to speak about at 9-something in the morning on Friday afternoon when y'all are all hungover, this probably would not have been the one I would have chosen. Probably a little ambitious for 9-something in the morning. So standard slides that I'm supposed to say to you from past. At this point in the week, everybody knows you're supposed to have your cell phones off. I don't care. I don't care if you listen to music in my session. It's all good. And then everything PASS has to offer. I'm going to echo what Kendra said in the session just before this. Every time that y'all are out here looking at other people speaking and you look at us up here and go, oh my God, they suck so bad, I could totally do this. You could. That was exactly how I got started. I went to a user group meeting and I'm like, that guy's just a goofy human being. I could stand up there and do that. They're not going to fire me for this. Presenting really does change your life. Get started by when you go back to the office, just do a lunch and learn with everybody on your team and say, here are some of the things that I liked a lot from the sessions that I attended. Plus, you can download all of the slide decks so you can go use those inside your own company when you talk about, here's the things that I learned. Session evaluations, there's a great saying amongst speakers, the best way that you can tip your speakers is by leaving them session evaluations. We really don't care about the ratings as much as we care about 2 comments. Tell us what we did that was cool and tell us what we did that sucked so that we know what we can do better next time. All of us are trying to do better. We're just like you. We're volunteers up here who are trying to suck a little less next time. I'm Brent Ozar. I co-founded a company called Brent Ozar Unlimited. Kind of happy how that worked out. In this session, I'm going to be talking about everything that's on that link down there at the bottom. This is going to be the only time that that link is up, so I'm going to go zoom into it. Everything that you're going to see me work on, the slides, the scripts, the demos, it's all already up there. It relies on the Stack Overflow database. You can go get that too, all from that link. So if you're gonna, I know y'all love to take pictures of me, so go ahead, no. I know you love to take pictures of that, do that once, and then you're gonna be completely done. You don't have to pay attention. You can get up and leave the session. The reason why I talk about this stuff, this is what I do for a living, is I get called in to fix SQL Server problems in 3 days. It's where a company's SQL servers are falling over for performance reasons. So I'm trying to distill down some of the more unusual ones that I get to run into, things that I never would have saw when I was back doing development. Because you know how what we always say as developers, it worked on my machine, compiled okay, ship it. And then we get out into production, or all of a sudden we have a Black Friday sale and all hell breaks loose inside the database. So in this session, I'm going to start by talking about a little bit about my SQL Server and my workload. I'm going to talk about the 3 big performance problems. But I know in a room this large, it's really frustrating to have to raise your hand, and then the speaker's always like, what? Turn down for what? So it's easier if what I decided to do instead is invite a friend of mine up here to basically be you. I've got a friend of mine who's sitting in here. Pinal, come on up. How many of you all know SQL Authority, aka Pinal Dave? Yes? Right? Good to be here, sir.
Absolutely, absolutely.
Bring it up closer to your mouth, too.
Absolutely.
There you go.
I'm going to be you. So let's see. I mean, if any question you have, just keep it with you.
Yeah, exactly. No one wants to. If you do have a question, you want to raise your hand, go ahead. But what's cool is Pinal has never seen this deck before either. So he's going to be asking the exact same probably kinds of questions that you are. Anything that you want to ask, sir, as we're going through, fire away.
Absolutely, absolutely. So I will, if you have a question, let me know. Otherwise, I have not seen, I have no idea what is going to be. So I'm going to ask the same question, and you guys know, right, that I don't understand many things anyways. Anyway.
And he can tell when I'm faking it too, so there we go. So my SQL Server and the workload that I'm on, this is so much smaller than your production workloads. I'm running a small VM, it's only got 8 gigs of RAM altogether, and I'm just giving 6 gigs of RAM to SQL Server. But this works out in my favor because I'm trying to show you what it's like when your SQL Server's totally overwhelmed. I'm going to use the Stack Overflow database, the 2016 March version. It's totally available for the free to the public. It's about 100 gigs in size, so when I run queries against it, it's easy to make queries really suck and fall over. I'm going to be doing a lot of work with the users table, which is actually pretty small. It's only about 1 gigabyte in size, but it's so much more fun than AdventureWorks. Hi, Mom. It's so much more fun than AdventureWorks. I never want to see another bicycle store demo again as long as I live. There's a reason why that company went out of business. If you want to see some interesting trivia, if you look at the sales history table in AdventureWorks, what does AdventureWorks sell? Bicycles. You know what their average sale price is? Like 90% of the data in AdventureWorks is under 99 cents. Well, of course they went out of business. It's a ridiculous kind of demo database. Who does that kind of thing? If only they'd give us that kind of price on SQL Server Enterprise Edition. So there are slides in here that talk about everything that I'm going to do, but I'm actually going to switch out and just do everything in Management Studio. The way that this works, and y'all already have access to this entire thing, I wrote out this demo script as if I was talking to myself so that y'all can rerun it again later and follow along with yourselves. It is completely open source. You can take this exact same deck, you can give it to your local user groups, your end users, fellow developers at your community. You can do anything you want with it. It is 100% open source under the MIT license. If you can figure out how to get people to pay for it, good on you. So what I'm going to start out with is I'm going to put my SQL Server under some basic normal stuff. I'm going to turn on the SQL Server 2016 compatibility levels so that I'm not demoing something ancient. And then I'm going to make a few unusual changes. Make sure this works down here. There it goes. I'm going to make a few unusual changes to the users table. The users table at Stack Overflow has exactly what you think it has. Everyone who's ever asked or answered a question at Stack Overflow. But I'm going to make a few data type changes. I'm going to change the user's display name to be very large, the user's location to be very large, and the website URL to be very large. They're normally not quite that big, but I'm going to do something to exaggerate a problem that I'm going to have in a little while. I'm also going to go create an index on the user's display name because I'm constantly looking up people like Pinal, John Skeet, myself. So now let's go down a little further. And I'm going to open up a web browser to show you a page that I look at a lot on Stack Overflow. On Stack Overflow, how many of y'all have either answered or asked a question at Stack Overflow? How many of you would like more reputation points? The good news is we have the database here. We can make that happen. I am the DBA at this point. So Stack Overflow's database, if I look at the live users page, this gives you the list of everyone ranked by their reputation. It's a simple page. People hit this all the time because they want to know if their reputation's getting better or worse, if they're on the leaderboard. We like to call this the leaderboard. And there's one person at Stack Overflow who's legendary, John Skeet. He's at the top of the leaderboard up here. Seems like he has superhuman speed, nothing else to do. He just sits around and answers Stack Overflow questions. So people are constantly running this query, show me the most popular users sorted by reputation. Reputation is just an integer field on the users table, so I can sort by that very easily. Let's go take a look at the database and see how that query works. Here's the query. Go give me the top 250 users ordered by reputation descending. Now, at first, it seems like it takes a second, but that's because I just started up this SQL Server, and there's nothing that's been going on it. And if I execute this a few more times, it's not terrible. It finishes in, say, a couple of seconds, and that's often good enough for a lot of users. People say, it's 2, 3, 4 seconds, ship it. That's good enough. It works for me. And it is good enough for us when we just get started in development. But now, what I'm going to do is I'm going to run a load test. And I'm going to use something called SQL query stress. And of course, and remember, for those of y'all who are taking pictures, everything in here, it's in the entire slide deck. SQL query stress is a totally open source load testing tool. It was originally written by Adam Mechanic. And what you can do here is you can say, point it at the database that you want. I'm going to point it at my SQL 2016 database. I'm going to pick the database that I want to go query. I like to have some fun with my database names. And then say OK. And then I can type in the query that I want to run here, like select get date or whatever it is I want to run. I can run it across hundreds of times across, say, 10 threads. But I'm going to pick the exact same query that we were running just a second ago. Go get me the top 250 users ordered by reputation descending. I'm going to run it 8 threads wide, like I have 8 different end users running queries right now. And I want them to just keep going and going. Yes, sir.
One question
Sure.
which comes to me is like, what are the, how many CPU do you have on this machine?
Oh, that's a great question. Normally I give out prizes,
Right.
but since it's just you and you're answering all the questions, all I can do is like give you query bucks or something. So here you go. Or candy. I have a whole bunch of Jelly Bellies, but then we'll just sit here and keep eating them. Those are actually not for y'all either. Those are brought to me by an attendee. I had an attendee at one of the sessions this week who works at, I might as well say it now, Jelly Belly, and brought a whole bunch of jelly beans. None of you in here brought me anything. You're no presents whatsoever, not even like vodka shots in the morning. So it's only 4 cores, just 4 cores, and that's it. Yeah. So this thing's been running, but it's not going very fast. You can see a little ticker on here about how many iterations have actually completed. It's not going very quick. And for those of you who might be sitting very close, pretty soon you're going to hear my laptop fan kick in and my laptop start to levitate from the ground. It looks like I'm doing a lot of CPU usage. And people are like, oh, well, this box just needs more power. But there's a different problem that's happening here too. While it continues to run, I'm going to run an open source stored procedure called SP-Blitz first. What SP-Blitz first does is it takes a snapshot of a bunch of your DMVs, waits for 5 seconds, takes another snapshot, and tells you what happened during that time. So for example, here are the 8 queries that are running right now, and it shows you what they're waiting on and how long they've been waiting. There's a wait type here that's curious. This thing's called resource semaphore. This is the unusual first problem that we're having. And if you go a little bit further down, SP-Blitz first says it detected a poison wait. Poison waits, it's like my throwback to Belle Biv DeVoe. That wait is poison. Not even a clap. Yes, my singing is truly that bad. Thank you. No costume changes today, thank goodness. But poison wait detected, that means there's something that's stopping your SQL server from going faster, and it may even seem like your queries are completely unresponsive during that time. SQL Server basically uses memory for 3 things. It uses memory to cache data, it uses memory to cache execution plans, and then it also uses memory for query workspace. When you do joins of tables together, when you do sorts, when you do an order by, SQL Server needs space in order to execute that. The resource semaphore wait type means these queries are waiting on memory before they can even start. These queries aren't even doing any work. In fact, go ahead, yes?
There are 2 questions because you're talking about memory. So the first question comes to my mind, how much memory you have in that box?
Yeah.
And second thing, what I'm thinking is that this is happening right now, but what happens if I add more memory to the box? Do you think this will go away or will it stay?
Oh, this is such a good question. This is why I have him up here, not any of you people. You're just sitting down there in the audience. Yes.
No, but would you have asked the same question?
Exactly, yes. That's what I would ask if I was sitting in here, yes.
Came to my mind, like you are running on a 1 megabyte, and what is the max setting here for your CPU? Are you limiting max memory?
So in this case, I have 8 gigs of RAM in the VM, which granted isn't a lot, and I've got max memory set to 6, so I'm using a lot. But there's a catch with this. If I scroll across, I bet a lot of you have used tools like SP-Who or Activity Monitor that show you which queries are expensive. One of the reasons that we wrote this SP Blitz first thing was we needed to know a lot more about those queries that are expensive. As I scroll across here, it's going to show me memory grant. How much memory was this query granted the last time it ran? What was the most it was ever granted? How much memory did it use? And then there's something interesting over here. How much memory would we really like to have? Our ideal memory grant. If we let SQL Server pick any amount of memory for this query, how much would it like to have? I know that there's no commas in here because I guess for Microsoft, commas are really expensive and they don't want to show those to you. But that number is 48 gigabytes. When this query runs, it wants 48 gigs of RAM. Hold up, that's kind of odd. Why would it want so much memory?
One more question which comes to my mind.
Sure.
If the query is asking for 48 gigs,
yes.
What's the size of the database?
I love it. That's exactly where I'm going to go. So as a reminder, I'm going to zoom in and show you that I'm not even joining anything. I'm saying just go get me the top 250 users. Is this big data like they show at the keynotes, big monstrous data? If I right-click on the users table and I go into properties, zoom out a little bit, go into properties, and of course this thing's going to take a second because my SQL Server's still falling over as it's trying to stop that load. Here's my properties. If I go into storage, the size of the table is 620 megabytes, not gigabytes, and yet SQL Server wants 48 gigs of RAM. How could it be that stupid? Let's go see. Not see by zooming in. Let me.
Is it a bug?
Is it a bug? No, this is Itzhak Ben-Gan. There's this great presenter who has a show called Bug or Feature where he shows you something and he makes you guess which one it is.
But I mean, it looks like a bug. I mean,
Right.
that is the impression, like, you know, the table is saying it needs this many gigs, but table itself is this, and you are just retrieving only 250 rows.
It gets worse. So I would say, this is going to sound kind of crazy, I would say the bug is in the developer who built the table and wrote the query. Of course, I'm a database administrator, so you would always expect to hear me say that, right? It's not a SQL Server problem, it's a data user problem. So I'm going to show you the execution plan. I'll zoom in a little here. Go get me the top 250 users. Well, I'm going to have to scan that entire clustered index. Yeah, but we know the clustered index is only 650 megabytes. If you hover your mouse out of this arrow, hey, SQL Server, how much data do you think is coming out of this query? Oh, 37 gigabytes. What? There's only 650 in the table. Remember when I said at the beginning of this session that I inflated some of these data types? SQL Server uses the data type size to guess how much data is coming out of the table. It's the number of rows it expects to find times the size of your data types times a percentage. Now, this didn't matter when we just ran one or two of these, but when you start to scale this thing up, when people ask you, does it matter what data types you choose? Oh, yeah, it does, once you start to scale, because SQL Server makes drunken estimates like, this table has 37 gigs of data. You'll also notice that I always use a male voice when I talk about SQL Server, because it's stubborn and it refuses to ask for directions. It's just, trust me, I got this. So 37 gigs of data, SQL Server thinks it's going to come out. So now Panal asked, adding more memory, is that going to help? SQL Server is just going to grant more and more memory because it thinks it has to sort a ton of data. If I hover my mouse over the select query, shows the memory grant. I got granted 1 gig of memory, but that's because there are rules built in, enforced with Resource Governor, that say you can only get so much RAM per query. So SQL Server, if you could get anything you wanted, how much memory would you like to have for this query? Go over to memory grant info, and that's where that desired comes in, where SQL Server wants 48 gigs of memory in order to run this query. That's not going to work. I could throw all kinds of memory at these queries, and they're not going to get started running faster. So now, how am I going to fix this? Well, I get a few different options. One is that I could do my data types in the right sizes to begin with, instead of wildly overestimating how many, I skipped forward just a bit. The whole point here is that I need to first tell you what the 3 horrible problems are. So the first one, resource semaphore, the whole symptom of this is when queries are waiting on memory before they can even get started executing. When I was looking at the queries that were running, there were 3 running, and 5 of them waited for memory just in order to get started. There's a perfmon counter you can look at to catch this, memory grants pending, that tells you how many queries are waiting on RAM right now before they can even get started. In order to fix this now I'm going to have to do something else. When I look at that query, it wants a ridiculous amount of memory, and it all comes down to me overestimating my data types. Eric Darling wrote a really good blog post about this. This is inside your notes there that you can go play around with this. But in order to tune memory grants, what I'm going to do is just get the fields that I need. Instead of doing a select star, I'm only going to get the fields that I need. And then also, I'm only going to get the rows that I need. Before, I was doing select top 250. Now that web page, though, it only shows 36 rows. Let's look at the execution plans between these two. I'm going to go get both of them. I'm going to run them both with actual execution plan turned on. Execute. Now the first one was never fast. It always took, say, 4 or 5 seconds. Now that I'm only getting the fields that I need in the bottom set, are my execution plans different? Well, they kind of look similar. They're the same shape, but the one on the top has the yellow bang. I ran out of memory. And if I look down further, I ran out of memory. I had to write 63,000 pages to disk. Whenever your memory grant is set, as your SQL Server query first starts, that memory grant is set in stone. And you don't get more memory just because you brought more data back. This starts to change in 2017 as SQL Server watches your queries over time. But this server's still screwed. If I want 48 gigs of RAM every time the query runs, there's only so much adaptive memory grants can do. But the bottom one didn't spill to disk. If I hover my mouse over there, there's no spill involved at all. And it's not because SQL Server sorted less data. Look at estimated versus actual rows. Estimated versus actual rows is still bang on. We still have 5 million rows coming in. But the difference, among many other things, is that SQL Server uses a different optimization method for sorts when you want 100 rows or less. When you want 101 rows or more, all hell breaks loose. Now, you would never know that when you're just looking at these 2 plans. You're like, oh my God, I have no idea what's going on. The top one wants a memory grant of 1 gig. The bottom one only wants a memory grant of 1 megabyte. Not 1 gig, 1 megabyte. That's fantastic. Now I can run more of these queries at once. Although, when I do it, I do still kind of end up with the same symptoms. So I'm going to take this same query again. I'm going to take the select top 36. Oh, there's a query. Yes, Hugo. So what Hugo says, he wants to dive deeper into doing this query. I would love to. The problem is if I'm going to show all 3 of these, I got to watch my time. It's a great question, though. Because there's all this experimenting that you can do between picking columns and between picking row counts to find the exact sweet spot for you. What if you did need 250 rows? Then you got to start making better judgment calls about what the data type sizes need to be and which ones you go and select.
So one question definitely comes to my mind. If the top query runs, is it really going to use as much as memory it is granting?
It will use up to, say, 650 megabytes, but that's about roughly all the data that's coming in.
Yes.
It would never use 40 gigs.
All right. Okay.
You know what else is really interesting is, imagine that you had a server with a terabyte of RAM, and this query actually gets 48 gigs of memory. SQL Server sets aside all 48 gigs of that just for this running query every time the query runs. You know how some of you monitor page life expectancy? How many of us watch the counter page life expectancy on our SQL servers? And you know how it just goes right through the floor for no apparent reason? It just utterly goes down to 0. This is one of the examples of what can cause that. If you have a query say, give me 48 gigs of RAM, SQL Server's like, okay, I got it, you want it, I got it. And off there goes your entire buffer pool. All kinds of data that used to be in cache is no longer in cache. So before, when I was running it, I had those poison weights. Let's try to run the tuned version of the query. So I'm going to take the tuned version of the query, go, and now that little counter is moving a little bit faster, like some queries can get through. If I turn back and look at my weight stats and my CPU, I'm not a big fan of monitoring SQL Server through Task Manager, but it's just interesting to see. My CPUs are still on fire because I am still asking over and over again to sort the entire users table by reputation. But at least now these queries can start to get through because I don't have poison weights anymore. If I zoom in here and I turn off actual execution plan, run my SP Blitz. I say it's open source, so of course there's lots of other people, but they all seem to blame the bugs on me. If I run SP Blitz first now, it shows that, in this case where I happen to catch it, 4 queries are up and running. Now I have a different poison weight that's detected. But as I go across and look at memory grants, now these queries are only using 1 megabyte of RAM instead. They're able to get the memory they need, get right back out, and I'm able to cache more data in RAM longer because I'm not clearing out gigs of RAM every time a query wants to run. So this is the first hard problem to go catch and solve. Whoops, coming back over to my T-SQL here. I've kind of sort of solved it. My SQL server's still under 100% CPU, but at least now I can manage more concurrency. More results can get through. It's still not perfect, though. We still have some work to do. Yes?
You mentioned that you get different behavior in the sort, depending on the size of your folder.
Yes.
So does that show up in the properties? Can you tell that it's using that, or do you just have to know?
Ooh, that's a wonderful question. When I look at the execution plan, can I tell that I got a different sort algorithm between the top 100 versus the top 101? As far as I know, no, but I don't think I've ever looked that deeply. I've just walked in and immediately said, select top 250, watch this, I'm a consultant, and you change it to top 100 and then whammo. They're like, how'd you know what the magic thing is? Sorry, it costs you more to learn that. That's totally not true. Totally not true. So
before you jump on a second one,
yes.
I think a lot of us are monitoring our PLE values, right?
Oh, yeah.
Yeah, so there is no right and wrong answer. There are many blogs out. But what is your opinion about continuously watching PLE counter and when to react or just not to react?
Yeah, it's such a good thing. Page life expectancy, for the longest time, there was all this advice out there. Page life expectancy is measured in seconds. From the time that I read an 8K page up off of disk, how many seconds can it stay in RAM before SQL Server needs to flush it out because it wants to read another 8K page up into memory? The general advice is the longer that you can keep stuff in cache, the better. And you'll see out there advice that says when it drops below 300, you're in trouble. Well, 300 is 5 minutes. What if you have a server with a terabyte of RAM and you're flushing that terabyte of RAM every 5 minutes or even every 10 minutes? 10 minutes might not be good. But some people still use the advice of 300 just because when it dips down below 300, you're screwed. It doesn't matter what your RAM is. If you can't even keep stuff in memory for 5 minutes, it's pretty dangerous. But you can have a higher PLE and still be screwed. What I will say, though, is I just don't start by monitoring PLE. I start with wait stats instead now.
Yeah, so wait state is like a new counters, right?
Yeah, okay. So much better for tuning, yes.
All right.
These are our backup dancers over here as well. I'm just kidding. Now I totally have to give them all my prizes of jelly beans. So now I'm going to go tackle the second big problem. Coming up on my birthday here, I'm a Scorpio, not that I'm married, I don't want to meet any of you. Yes, I do come here often. But I'm coming up on my birthday, so I'm going to set my age to age, now I'm going to do it twice. I'm going to pretend that I didn't highlight the commit, and I'm just going to click begin tran and update. Because you know how it is sometimes when you run queries, sometimes you just leave a transaction open for a while. Sometimes there's a bug in your code and it doesn't actually commit the transaction, it leaves it hanging open. Maybe you're doing row by row processing, or maybe just committing the transaction is slow. What I've done is I've started taking out a lock here. Now I have an index on display names, so SQL Server is able to quickly get just to my row. There's only one of me. Now when I do that, after I do that, now when I try to run the leaderboard query again, it works in my session. As long as I'm still in the same window, I have not committed my update, I am still allowed to have a party in the database and do whatever I want. But if I take that query and I try to run it in a different window, I'm going to pop this over to the right-hand side so we can kind of see that it's different. If I take that one in the right-hand window, he's blocked. By default, there's no concept of a lock timeout in SQL Server. Blocking will go on forever. But people usually don't freak out because usually they commit their transactions quickly. Watch, I almost want to go in slow motion. As over in the left-hand side, I come back to my begin tran and I commit it. The instant that I hit commit, immediately the select is going to finish and clear out. Boom. Because my lock got out of the way. But let's simulate what happens when this doesn't go well. I am aging at an incredible rate today. I'm going to click execute. So I've now got a lock on my row, the user's display name of Brento. Now, I'm going to take our leaderboard query. I'm going to go fire open SQL query stress again. I'm going to say cancel, just because this is, so here's the deal. I love open source, but the thing is when it breaks, you get to keep both pieces. It's not like it's amazingly reliable. And this code is okay, but as you notice, I've already hit cancel and things aren't going particularly well. I'm going to go kill it. You're taught never to do this in kindergarten. You're also taught to share things. I did not learn that either. I'm going to open SQL query stress. I'm going to open up my load test, but I'm going to do a little bit more load. I'm going to do 200 threads. Now, what's the big deal, though? With 200 queries, it's not like they're really doing work. They're all blocked right now. And if I go in and look at Task Manager, when it first starts up, go over to Performance, CPU is high at first, as SQL goes out and starts allocating all kinds of worker threads. It needs lots of worker threads to track all of the incoming queries and the requests that they want to do. But over time, over the next several, 30 seconds, 60 seconds, this number is going to start to drift down because these queries, they can't make any progress. Did I do the commit? Let's go look at SP who is active. Ho, 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 hee, hee.
I have a problem here in SQL Server Management Studio.
The fun thing about doing these kinds of demos is that I'm purposely breaking my SQL Server. You're now seeing the symptoms. SQL Server is now acting like it's not going to respond to requests.
So that is why this reminds me of incidents of where this comes by.
This is
so,
when you forgot to commit your transaction, right?
That's one of them. And like a lot of customer I see, a lot of people just directly go to the server where they have a SQL server installed on the same machine, and they open SQL Server Management Studio just there. And as soon as SQL Server Management Studio shows this behavior, they usually restart SQL services. And I was like, whoa, they have no relationship. But sometimes it works, and sometimes customer cries, or the customer cries, and it's so interesting. So I think one advice is I always tell, I think we should never, ever connect SQL Server Management Studio on the same machine which we have, right? It's a services installed here, connect from outside, never connect from there.
On a related note, because this happens often, I know some of us do this when we're not happy. We go in and we connect into the SQL Server directly from Management Studio, and I was troubleshooting a case one time, and they were running into this exact problem, and I said, well, just out of curiosity, I'm going to go look at your task manager just to see. And when I go look, this was on the SQL Server itself. And there's like 24 people running SQL Server Management Studio at the same time. Some of you may be systems administrators. You may know that you can't have multiple connections in beyond like 2 by default. So I keep the poker face on and I go, did you enable remote desktop terminal services just to run SSMS from the SQL Server? Yeah, they said, we're trying to save on licensing costs. And this way everyone just remotes into the SQL Server. Well, the good news is that Management Studio is free and you can run it from your desktop. Immediately a developer says, no, I wouldn't want to do that. My desktop's really slow and the SQL Server is fast. And plus, there's no firewalls where the SQL Server is at. We can get to anything from where the SQL Server is at. And I said, oh, so if you're doing that, I know what else you're doing. You're all also surfing the web from the SQL Server as well. Doing bad things like reading my blog. So now when I look, CPU's gone down to nothing. SQL Server's gotten its act together. It's lit up all kinds of worker threads for this query. There was a problem, though, in the meantime. I wasn't even able to get in there for a second. Let's try it again. Who is active? Now I'm using a wonderful stored procedure here, SP who is active. This is also in your resources. This was written by an MVP out of the Boston area, Adam Mechanic, and I like to call this Adam Mechanic's amazing tool. When the SQL Server's really under stress, this is one of my favorite tools to go dive in and see. It tells me, kind of like SP Blitz first does, that I've got lots of queries waiting on locks. How many? Well, about 137. It hasn't even been able to light up all 200 yet. And if I start to try to light up even more, if I go in and if I look at SQL query stress, I'm going to open up another instance of it, and I'm going to light up another 200 queries. Go. So now I have one window over here on the left-hand side that's waiting. I got another window on the right starting another 200. I feel lucky punk, so I'm going to open another one. Why wouldn't you? This is why no one wants to buy my used laptops. So this SQL Server's under some pain now. I have 600 queries that are coming in trying to run the leaderboard query at once. Technically, none of them can make progress. But SQL Server starts to feel completely unresponsive even when Task Manager isn't going to 100% CPU. Just to light up and show these numbers here. CPU isn't that bad. CPU's like 5 to 10%.
So that means we are good.
That means we're good.
Yeah, exactly.
We can go out for beers. Yes, we're out of here.
Isn't it like CPU more is bad and CPU less is good? How many times we... Yeah. I mean, that's what I see. If I see CPU running 5%, 10%, I think it's good. I mean, if CPU is running 90%, that's super, super bad for her, isn't it?
But you're a consultant, it's the other way around. When SQL Server or CPU is really high, that's when they call you.
Exactly, so that is very, very good. And,
Yes.
and so, I mean, I like it when people see CPU running high and they say, fix it. And I was like, it's fixed already. It's not starving.
It's down. And now, as I'm trying to run SP who is active won't even run. Now, this is the next poison weight type. Thread pool is the weight type that I'm experiencing now. SQL Server has run out of worker threads. Even though I have plenty of available CPU power, SQL Server has a limited number of worker threads that it can light up per query, or 4 queries. I told you to set your ringtone to Duran Duran. Come on, you guys are disappointing me. So this SQL Server, I can't even connect to it, even though CPU is very low. The symptoms on this, the same as a human being can't connect to SQL Server, your monitoring tools can't connect to SQL Server either. So here's the symptoms for this particular problem. Somebody's calling you and saying, dude, I can't connect to the SQL Server. Seems like everything's timed out. You have a monitoring tool that goes in and looks at CPU usage. It reports very low CPU usage. But any SQL Server monitoring tools, when you run stuff like Spotlight, Idera SQL DM, SQL Sentry Performance Advisor, all those tools, they just have gaps in the coverage. They show no numbers in that time whatsoever because they can't connect either. To solve this, SQL Server has a little kind of tricky back door that I can use in order to connect. Over here in my window where I was trying to run SP who is active and it says not connected, I'm going to use the little change connection. I can never find the change. Oh, it won't show because I'm not connected. Right click, change connect. Oh, I can't even, SQL Server, you suck so bad. So bad. That's not true. I work with a lot of open source databases. They suck way worse, way worse. So I'm going to change connection. And now instead of connecting to SQL 2016, I'm going to connect to admin:SQL 2016. This is called the Dedicated Administrative Connection, the DAC. It's a set-aside CPU scheduler, set a worker thread, and some memory set aside just for emergency troubleshooting. But it can only be accessed by one user at a time with one connection at a time. And when I say one, I mean one. Watch what happens. When I go to click the connect button, I'm going to get an error. But watch what the error is. Dude, I couldn't connect to SQL Server 2016A. That's not what you think it is. What this really is IntelliSense. Every time that you go to connect to a SQL Server, IntelliSense sneaks in right behind you, connects to the exact same SQL Server, and IntelliSense is the one going, herp-a-derp, I'm screwed. If I click OK, and I'm going to zoom out to show you, if I click OK, and then I look closely down at the bottom, I am connected. It's just that, stop laughing, that's not funny. It's bad code. Bad code is never funny. Bad code is always funny. Unless it's yours, in which case it's mostly tears and sadness, which it usually is mine. So it did connect correctly to the DAC. It connected to admin:SQL 2016A. And from here, now I can run troubleshooting queries. Now I can run, for example, Atom Mechanics who is active. And as I look at it, it shows I'm not getting a whole lot more queries. I've kind of hit a wall here at about 140. They are all waiting on locks. If you look at the wait info column, my one query where I first originally did my update, he's not waiting, he's sleeping. But everyone else is waiting on locks and it will not go away. Go ahead.
In this situation, don't you think so we should kill the first one?
Oh, I thought Indian people were peaceful, not violent. Why you want to kill somebody? So the thing is with killing, when you kill a query, roll forward is multi-threaded. You can have a query that did a whole lot of work with, say, 8 cores for an hour, but when you put a bullet in it, rolling back is single-threaded.
So if you had 8 cores working for an hour, you kill it, it's possible that it could take several hours for this thing to roll back. And the crappy thing is, I can't tell all the queries the user did leading up to this point.
I got a better idea now. So let's not kill this.
Yes, I like that idea. Yes.
Let's restart the services.
Oh, I thought you were going to say kill the developer.
No. I mean, once you restart, restart works for phone. So I think I do this thing in my business.
I think we should move to Linux. Yeah. Because then it won't be up anyway. Then we'll have a different problem. I'm just joking. I adore Linux. This is a Mac. Usually I make the Windows jokes. So to fix it long term, I got to figure out why that query is holding a lock for so long, which queries are being blocked, and how I'm going to make them better. But it all starts with using the DAC. I have to connect in to figure out which queries are getting blocked. I wish a monitoring tool would tell me. I wish my monitoring tools would know when thread pool is happening, but they can't get in either when the situation is this bad. In a perfect world, we would have caught locking leading up to this point. We would have seen, man, this application sucks. We have all these blocking problems. We should tune our queries, tune our indexes. But we're lazy. We like to go to Seattle and go to conferences rather than work on our applications. So when you hit this, when you learn about this, where you have these wide open holes, what you have to do is teach your staff how to connect to the DAC, run SP_whoisActive, and either save the results to a table or copy paste, picture them into a spreadsheet, whatever it is. The first reaction people have is, I should run SP_whoisActive in an agent job every 5 minutes. Guess what? Can't connect either. Nothing can connect in unless it uses the DAC. And I'm not a big fan of automated tools connecting into the DAC, because what if I need it when I'm trying to do troubleshooting and my badly written app keeps trying to connect to the DAC and hogging my connection? So with this, I'm going to go kill my load testing, and then things are bad, things are really bad. Close all my open source stuff here, cancel, close, please wait, yes, I know. Open source, good stuff. I'm not, seriously, I love it. Promise, love you, mean it. No, and truly, the SQL query stress is absolutely fantastic. I'm obviously doing demos that are purposely designed to break my SQL server in spectacular ways. So, of course, it's a miracle that any of this stuff works. Usually, you go to presentations and the users or the presenters like, oh, I hope my demos work. No, I hope my demos don't work. That's really how this works. Yes? Is the lead blocker always at the top of SP_whoisActive? No, because if whoever's got the lead block runs another query, they'll suddenly be at the bottom. Diabolical. Yes?
The mechanic has a blockchain parameter that you use.
It has a blockchain parameter, and it has lots of other, I like the get locks parameter too. Troubleshooting that, to troubleshoot it, here's the ways that I would go off and do that. I'm not a fan of some of these, as the fact that you can tell by I say, usually a very bad idea. We could commit our transactions faster, I could do some index tuning, or I could change my default isolation level. This is not a talk on isolation levels, but just to give you a quick heads up, SQL Server's default concurrency is pessimistic, meaning writers can block readers and readers can block writers. Azure SQL DB, always on availability groups, secondaries, Oracle, Postgres, all kinds of other database platforms, choose a different default isolation level called optimistic concurrency, multi-version concurrency control, or RCSI. What I'm going to do in order to show that is I'm going to roll back my little update, and then, let's first try, well, you know what? No, I'm not. That's what happens when I read ahead. So if I wanted to make this query go faster, specifically the select, if I hit execute on this select, and I look at the execution plan, close out of all my goodies here so you can see the whole thing, SQL Server saying,
I'd like to scan the entire clustered index. Hey, SQL Server, do you want a missing index for that? You want to maybe sort it by reputation or something? No, no, no. I got this. I'm good. So SQL Server wants to stay scanning a clustered index all the time. We could do better than that. SQL Server doesn't generally recommend indexes to fix the sort operator. If I hover my mouse over this, SQL Server sorting the entire 5 million rows by reputation descending every single time. Well, there's a fix for that called an index. Dun, dun, dun. So here's the index that I'm going to go create. I don't always create covering indexes. Covering indexes mean that this index works perfectly for this query. But in this case, hey, I'm the typical database administrator. Indexes are free. Let's just go add a bunch. And now when I run that query again, instead of scanning the entire table, it does an index scan, which sounds bad. When you first get started doing index tuning, you're taught that a scan means reading the whole table. A seek means jumping in and getting back out. That's not what it means at all. A seek can read the entire table. A scan can read just a few rows. And in this case, because we're only getting the top 36 ordered by reputation descending, SQL Server, I adore these icons. It's why it's the wallpaper on my laptop. I adore these icons. They say just start at one end of the index and read. How much are you going to read? Well, that's where you got to hover over it and see. Number of rows read, 36. It only read 36 out of 5 million users in the table. It's smart enough to just read some of the rows in the table and bail out. And there's no sort. This query is so much faster now that I fixed that index problem. So let's induce our blocking again. Let's go through and make our begin tran again so that we're going to make, golly, I'm tired of getting old. So I'm going to go update my age again, take out a lock. Now I'm going to pop back over to SQL query stress. Whoopsie. I'm going to go load my demo, thread pool, and go and, SQL query stress. So this is kind of interesting how this works. In a second, it's going to start updating. Here's where you're going to notice something. SQL Server, it's not really working at all. Guess what is? SQL query stress. Because the results are coming back so fast that this thing stopped updating there for a second. Dun, dun, dun. 5,000, 6,000 executions, they're just incrementing like crazy. Even though there's a block happening, there's an index that perfectly satisfies my query, so the select can blow right on past there. We've solved the problem. Now I still have a new problem. Now my application sucks. My application isn't even fast enough to consume the results as quickly as I would want it. This are the different ways that you can go about solving thread pool weights. When I go back out and summarize it, pop back out here. Oh, and let's back up here. Hold on a second here. There you go. So the ways to fix thread pool weights, in here, I would go for this. Tune queries to reduce parallelism requirements. Instead of these things having to go wild and crazy parallel and burn lots of worker threads, just seek in or scan in, just get the end that you want. Yes?
Yeah, two questions when I see the max stop and parallelism. What do you suggest for a cost threshold for parallelism and second max stop of the server level?
So what do I suggest for max stop and cost threshold? Microsoft's max stop recommendations, this is the only KB article I know by heart, 280, 65, 35. If you search for max stop KB, yeah, that part is funny. What are you going to remember when you're an adult, Brent? 280, 65, 35? Great, useful. Where's your car? I'm not really sure. So Microsoft's KB article on MaxStop says go up the number of cores in a processor up to 8, but no higher than 8. Some workloads actually make sense higher than 8, but you have to experiment to figure out which one's right for you. For cost threshold, the general advice out there is 50. We are all making this number up. So you'll see some presenters say 40 and some say 75. It's not like we have passionate disagreements. We just all agree that the default cost threshold sucks bad and it should be something other than 5.
Right. And max degree?
A max, so up to the number of cores in a processor,
Right.
up to 8, but no higher than 8. That's the default starting point. Then if you have things like a data warehouse where you do the same workloads every night, you keep reloading tables and running reports, you could set your max DOP different every day for a week, monitoring your workloads and see where the sweet spot is.
If you go to Stack Overflow, I think one of the questions is some weird stored procedure which gives you suggestions of what should be your max DOP, and it always gives me suggestion more than max DOP I have on my system. What should I do?
Oh man, so I've seen a lot of those kind of auto-recommending tools. I would hold out for, I hear Microsoft is developing artificial intelligence that will make us all redundant.
Right.
I hear in the future,
Yeah.
we're just all either going to be working on the robots or we're going to be DJs. And that's just basically the only two
Yeah, so-
jobs that will still be available.
That's good. So yeah.
Like every time I see code like that and I look at the code, I'm like, where the heck are you getting this recommendation
Yeah, so
from?
I had a 4 CPU, a 4
Yeah.
processor, and they're saying set it to 8. And I was like, okay, I'll set it to 8. Will it run faster?
We should like write answers like that on Stack Overflow just to see how many people believe it. Well, it's Pinal and Brent. They must know what they're doing.
So it happened to me one time. Person says that this index has been. I look at the system. I said this index is very, very bad. He said, yeah, absolutely. Look at that. It says created from Pinal script.
Oh.
I just kept quiet after that for 2 minutes.
All right, let's see. What do we want?
What is
Oh,
it?
perfect.
I just tried.
Make sure, 10:45. Okay, good. Whew. Had a thought there that I was around late. No, we're good. We're perfect. All right, so for the last poison weight, this is problem number 3. Problem number 3. It's amazing what you can find out there for ASCII art. Don't go Googling for that now, especially when people are looking over your shoulder at the phone. So I am going to, this is, why do people come to Brent's sessions? They haven't laughed this hard since they were reading books online. Why do I do this? This is why I can never go to work for anyone else again. They would fire me immediately. Begin Tran, I'm going to update just Brent's row. Now, there's only one user affected by this. So when I only update Brent's row and I go into another window, I'm going to pop open another window, just clear out a couple things here, do some good housekeeping. Pop open another window so that it's over on the side to make this easier to see. And then I'm going to run my SP who is active, that's a wrong term. The only reason I said my is it's installed on my server, it's Atom Mechanics. At least once a week, someone comes up to you and says, I love your SP who is active. No. If it was my code, it would take 2 hours to run. If I look at SP who is active with get locks equals 1, it returns this really cool XML property bag that when I click on it, it shows me the locks that that update query has. I don't expect anyone to interpret this at a glance. What I'm going to show you here is I have a lock on the users table. On the primary key, I have exactly one row, because there's only one of me by law. I have, across the entire object, an intent exclusive lock, which means that my query has said, I'm updating one row just to give you the heads up. I haven't committed my transaction, so I may need more locks. Eventually, I may lock, say, the entire table, so no one's allowed to go in there in front of me and change the table. That's safe in the sense that when it runs, I can still do my select. Let me pop back out of here and get the select again from my buddy. Copy paste. He's writing down, never get up on stage with Brent again.
That's the next question.
That's the next one. How did I get here? So even though I still have a transaction over on the left-hand side, even though I have this begin tran open with Brent's update, I'm still able to read my select. I've only locked one row, and I have this nice index to do my reads from. Yes?
question which was, but we use no-lock all the time.
We use no-lock all
All
the time. Yes.
So will it affect that?
Can no-lock queries get passed? Look, I know that DBAs have this allergic reaction to no-lock because there's 3 basic problems with no-lock. One is they can read data twice. Imagine the phone book scenario. The white pages of the phone book, the thing your grandpa kept on the shelf to call his friends from the war who'd all died, and then he would get sad. Was that just my grandpa? It's just my grandpa. So it would start in the white pages of the phone book. In the A's, it would read through and see Jane Doe. Reads past Jane Doe. Jane decides to get married to, we'll say, Mr. Smith and change her last name. Unlike my wife, she kept her own name. She's like, you're lucky I even wear the ring, sucker. So it's true. It's not even a joke. So Jane, I have so many good stories about my wife, who I love dearly and is probably going to watch the recording. Hi, honey, I love you. Magical. So Jane Doe changes her last name to Smith. As I read through, I see her again. I can see Rose twice. Now, let's take the opposite example. I start at the phone book. I read past the D's because she's still married. I'm in, say, the M's. Jane Smith gets divorced, changes her last name back to Doe. I continue reading. I don't see her at all. Or if I'm reading through the whole table and an entire page moves, my query can fail. Error is could not continue scan with no lock due to data movement. If you're okay with 3 things, no lock is cool. If you're okay with seeing data twice, if you're okay with seeing it not at all, and if you're okay with your queries failing, no lock is all right, which sounds like I'm joking, but hear me out. It's the perfect use for financial reports. Because, right, you see where I'm going with this, your executives are printing these out. They don't know right from wrong. They're making bad decisions anyway. They might as well be random numbers coming off of there. Now, cat pictures, on the other hand, no lock is not appropriate for cat pictures. We need to see all of the cat pictures and not see any of them twice. Now, so that's the general spiel on no lock there, in which I managed to offend my wife and talk about cat pictures.
It's a wedlock.
That's how I get in trouble. So over on the left-hand side, I did the begin tran for Brent Ozar. The select over on the right-hand side still works just fine. I'm going to roll it back. And now I'm going to have a different person have a birthday. I'm going to have my friend Alex have a birthday. Now, just to make it clear what I'm doing, I'm only going to highlight the begin tran and the update. I'm going to execute. And now over on the right-hand side, I'm going to go run the select again. Something different happens. Now my query is blocked. It's the same query, I just updated a different name. Quick show of hands, how many of you in here are named Alex? There's several of us in here, several of you in here. How many of you are named Brent Ozar? No one raised their hand. I thought there's Brent. Yes, me and Brent Unruh over here. There's something different about this. If I go stop this query and I go run sp who is active with get locks again, and I look at what locks my update has now, here's my running command, my update command. If I scroll across and look at locks, now my locks look different. Instead of locking just one key, I have an exclusive lock on the entire table. These queries are a little different because there are different numbers of people who are affected. Notice when Brent Ozar ran, there was only 1 row affected. When Alex ran, there were over 5,000 rows affected. In order to understand how SQL Server is going to do locking, you have to think about how many rows are going to be impacted by your statements. So the answer on the final problem is, or the symptom on the final problem is, when I'm dealing with lock escalation, I have queries that used to work totally awesome, and suddenly they start blocking today. Zoom out so you can see everything in here. Oops. Come back to me. Return to me. So in order for me to fix this, what I could do is I could work in smaller batches instead of working in, say, thousands of records at once. I could try to tune for smaller batches. Michael J. Swart has an excellent post about that. I could work in large batches but commit my transactions quickly. Instead of holding the lockout, I could get in and immediately get out. Lots of different ways that you could read about tuning that over at Microsoft's KB article. They actually have a good post on lock escalation. And then if you're trying to do deletes across thousands or millions of rows, there's a really good technique called fast ordered deletes. Yes? If I update a user that's in the top 36, as it turns out, no. Dun, dun, dun. Now I want to go do a demo for that, but I'm not going to. If you want, come up afterwards and I'll show you, because I have a demo on that exact thing. It's because I have a covering index that doesn't have age in it, so I get to kind of cheat there. Yes?
What if you update it using row lock?
Oh, that's fair. I'm going to put it in there. So I'm going to say it. So you could also use row lock hints. Disclaimer, I don't like this. I don't like this, but I want good ratings from this attendee. So no, it's true and it's fair, especially if I knew it was like 5,400 rows and it was just past, I'll get you, hold on, you go. If I was just past the row escalation threshold, I might be open to that. But where I worry is coming behind me, somebody updates 500,000 rows next. That's where I worry, especially in a growing population like Stack Overflow. Now, one of the men I adore, Hugo, yes. Oh, that's great, because he's not, if you want to leave a comment for him, he's speaking too. Yes. Yes, what do you want to say? I was afraid you were going to give him an even worse idea. You could also turn off table level locking. Let's pretend I never said that, especially on the recording. I just zoned out, yes, because you still want to be friends with me. So I'm going to try the second to last one here, using the right isolation level for my application's needs. Now, again, like with all of these problems, I cannot go into the depth of detail that it would take to show you how to test your code to see if this isolation level is right or wrong for you. But in here, I'm going to do it just to show it. What I'm going to do is make sure that my transactions are rolled out. I'm going to close out of all my other windows. The database has to be in single user mode, and I just want to make doggone sure I'm not in anywhere else. And then I'm going to run this command. Alter database, drop all users. Set Stack Overflow, set the default isolation level to RCSI. This means that everyone gets advantage of this optimistic concurrency that I talked about earlier. It comes with a lot of drawbacks. Some people say that there's possible race conditions in code. We have tons of stuff about that in the resources. But now that I've done that, I'm going to take my lockout on Alex again, execute. And now I'm going to go back over into another window. Siri, there's no way to turn off Siri, and I don't even use her. She is an idiot. I'm an Apple guy, but I tell you what, Siri is, if Siri was my child, I would take her out behind the shed. That's not true. This is why I also don't have children. I'm sorry, honey. There it goes again. Manage. So she's, no, it's, oh, so many jokes I want to say. My wife doesn't want children. She's like militantly opposed to children. I made her get a dog, and she's never forgiven me for that either. She's like, when this dog passes away, if you want a dog, it better be you, her sleeping in the bed with you, because I'm going to be gone. Now, over on the right-hand side, now I'm going to go run that select again, and now, whammo, the select gets right on through as I'm executing this. Even though if I go into who is active, get locks equals 1, if I go look at what locks this session has, my whole life is spent moving arrows around. There we go. That update still has an exclusive lock on the users table. But the beauty of optimistic concurrency is that readers don't block writers and writers don't block readers. It's like a party in the database and everyone's invited. Now, two writers will still block each other. If you have two updates that are going against the same row, you're still screwed. But as long as you avoid that, you're good.
Now, holy cow, we have been all over the place through this entire session. To recap, let me get it all zoomed in here and get it all so that you can see it. I'm a huge fan of doing stuff in text files. So, go ahead. Yes.
One last question. When I see this,
You promise it's the last one? Good answer. Yes.
When I see this one, it seems like this particular setting will solve our problem. Do you recommend this to enable this for entire database all the time?
Oh, I believe that every brand new application built from the ground up should start there. It's the same thing that Azure SQL DB does. It's what Always On Availability Group Secondary does. I'm a huge fan of it because it just heads off all kinds of locking issues right at the pass. If you have an existing application, I only recommend flipping that if you're facing this problem or a problem similar to it, and you've done a lot of research to figure out if it's right for you. You look like you're right. No. Okay. So to recap, the 3 hard problems that we saw in here first, resource semaphore. This is when your SQL Server queries can't even get enough memory in order to start. To fix that, we have a few different options. I could tune the queries so that they want smaller memory grants. I could also throw more memory in the server, but as we saw in here, that wouldn't have made a difference with our horrendous data types. Second was thread pool. When SQL Server runs out of worker threads, you don't fix this by buying a larger SQL Server. You tune the parallelism requirements for queries by tuning indexes and tuning the queries themselves, or playing with cost threshold or maxstop. And then finally, for lock escalation, this is when we start out working with small numbers of rows, but over time, all of a sudden, we start tripping thresholds. There's plenty more resources about each of those. You can go to brentozar.com/go/3hardproblems. I will be up here for questions afterwards, so I won't make you all stand up and raise your hands. But otherwise, have a great last day at Summit, and I'll see you guys next year. Adios. And thank Pinal. Let's have a round of applause for your virtual attendee up here.
Thank you. Thank you very much.
Oh, my pleasure.